And I can't wait to have some conversations about some of the amazing technology that you have here at HAIMER. So let's get cracking. What do we have here?
So this is our Tool Dynamic Comfort Plus balancing machine from HAIMER.
So what are the consequences of imbalance then? Why is balancing things important?
Well, there's a few that are pretty obvious because it all comes down to basic physics. So, of course, you'll have spindle vibration, you'll have vibration down at the cutting edge, and that leads to poor surface finish, poor tool life, maybe cutting out of tolerance. And again, the obvious one is also the potential spindle damage because the spindle only has, or the vibration only has two places to go, either up into the spindle and down into the workpiece. But I would say the biggest problem with running with unbalance is you typically slow down your feeds and speeds. And when you do that, you're giving away productivity.
Which is money lost.
Absolutely. That's the most important thing. You want to make sure your machine's running to its max.
So Brent, can you explain to me what some of the main features are of this particular balancing machine and how it might compare or be better than some of the others on the market?
Well, that's a great question, and I think it all stems back to two things. One, HAIMER is the only tool holder builder in the world that makes a balancing machine. We've been making them since 1996, and we started to make it based on the fact that we needed to fine balance our tools once spindles got faster. When I say faster, we're talking 8, 10, 12,000 RPM. Of course, now they go much faster, but back then there was a real need to have your tooling assemblies balanced. So that is where it really starts as far as how we're different than others.
Okay.
But the real difference is we made it back in 1996 to be specific for tool holders or grinding wheels. And it was the first balancing machine on the market as such. In other words, other machines were to balance parts, and that's fine, but they weren't clamping the tool holders correctly. So that's when Mr. HAIMER went to the drawing board and said, I've got to make one that actually clamps the tool holder as it would be in the machine spindle. And then he constructed it as such that it would be a very, very accurate method of balancing to the tight tolerances that were required.
Now, my next question is, now there's a lot of different brands out there that create different technologies to help manufacturers with balancing. Is this something that can be compatible with any kind of brand, grinding wheel, tool holder, anything, or does it have to necessarily be HAIMER?
No, it does not have to be HAIMER. That's a great question. In fact, that's very important for us. So we're a real producer of products. So we make over 4,000 tool holders a day. So when Mr. HAIMER and his team make anything, they've got two goals. It has to be accurate, otherwise the whole process is a waste of time. It has to be easy to use. And it has to be able to be universal so that you can balance anyone's tool holders, any sort of tool holder on the market. And that's really, really important because we don't want to limit the customer to just having to use HAIMER tool holders. Now, of course, we've got some solutions that make it very convenient, but this will balance anyone's tool holders.
So can you walk us through a quick demo then and show us how this works?
Sure, no problem. So basically, again, back to the ease of use, we have basically a software that's very intuitive, and you're only on about 3 screens when you're using the software. And what we would do here in this example, we want to balance this assembly, and I use the word assembly because that's very important. So this is actually as the tooling assembly will run in the machine tool. So we've pre-balanced the tool holder to the G2.5 at 25,000 RPM, but in this example we have a shrink fit extension and a cutting tool mounted. So this is how it will actually run in the machine.
Okay.
So we clamp the tool as it would be held in the machine tool spindle. We go ahead and hit start, and now the tool ramps up to 1100 RPM. This is actually taking its measurement, and we use centrifugal force sensors. So there's the accuracy part. One, it's clamped as it would be in the machine tool spindle. 2, we use centrifugal force sensors to measure the force being applied as it rotates. Halfway through the reading, we index the tool 180 degrees, and this is just to take the unbalance of this spindle out of the equation. So now when I run again, I'm truly just getting the unbalance of this assembly. And then when it stops now, I'll get my results.
And that will show up there, over there?
That will show right here on the screen, and it's very obvious. So red is bad in this case. You know, okay, we're not balanced to the specs we wanted to be. We were trying to be balanced to a quality grade of G2.5 at 25,000 RPM.
Okay.
And that's all just a formula that dictates permissible unbalance.
Okay.
The fact that it's red tells me we're outside of our tolerance. We're only balanced, it's probably hard to see, but we're balanced at G2.5 at 2,406 RPM. So again, keep in mind, this was a perfectly balanced holder, but here we're unbalanced, or we're only balanced at 2,400 RPM. At the 25,000 RPM, we're at a quality grade of G25.9, so that's 10 times worse than we're supposed to be. So we're heavy here at this location. The machine will tell you how to correct the unbalance either by drilling to remove weight, either axially or radially. It will also tell you how to maybe mill or grind if it's a tremendous imbalance, like with a boring head.
Okay.
Or it will tell you to add weight, where you can add weight with little screws. Or in this case, as we have it set, we're going to balance via rings. So it's heavy here. I'm going to move these rings to these two locations to bring the tool within balance. So I just click on one of the angles. It rotates to one of the positions. And now I adjust the ring to that position. We basically adjust the ring.
Is that what that laser is for then?
Yeah, the
It shows
laser
you?
indicates where it's supposed to be positioned. So now it tells me to bring one ring here. There's a scribe line. So I just locate this here. And that is the tricky part with the one hand, but anyway, it's very self-intuitive. So I line up this screw with the laser mark. And the other position is right here. So before I do that, I'm going to loosen this screw and bring it over. So again, the laser gets brighter when I'm in the correct position. I tighten down the screw. And then I just double check to make sure that the correction I made was correct. So again, this was a method of what we call displacing weight. So removing mass opposite of where the tool is heavy. And what's nice about the ring system is you can add these to existing holders. So you don't have to necessarily start from scratch. As long as there's a place to put the rings, you can add them to anyone's holders and any diameter. We've got over 100 different diameters available, and we've also made special rings if needed.
So that's a great point on it's compatible with any brand that's out there on the market. So it really helps any company who needs to balance their work holding tools.
Absolutely.
Well,
and here you see, Meaghan, before to cut you off here, but we now see green. So green is good.
green is good.
That means we're within our tolerance. So we're at G1.3 at 25,000 RPM. So that's all it took. So again, it's very easy to use, and anyone can use it.
Awesome. Well, Brent, let's wrap this up. If you had 3 reasons to give people to invest in a machine like this, what would your top 3 reasons be?
Well, number one, I'll start with number one, is to be able to get the most out of your machine tool. I think that goes without saying that that's something that's very, very important. Many people are spending a lot of money on these machine tools, but yet they're not getting the max out of them. And they don't even realize it. They're making good parts when they slow things down, which is their job, but they're giving away productivity. Number 2 is tool life. We've had a lot of people who've said that they've justified the cost of a balancing machine within 6 months just on the savings of cutting tools because of the lack of vibration. And 3, of course, is consistency of the production process. So you know that each time you're going to be able to get, let's say, 250 parts machined with that end mill, it's the same each and every time. And so that's, I say, would be the top 3 reasons.
Awesome. Well, Brent, thank you so much for explaining and demoing this great machine. Stay tuned because we got a few more demos from HAIMER here in Illinois. I'm Meaghan Ziemba, and this has been MTD CNC.